Okay, so welcome to this question. This question is a little bit tricky. The question here says that find the minimum gradient of the curve. So we are not actually finding the minimum of the curve. If we want to find the minimum of the curve, means we want to find the minimum point of the curve, right? But we are finding the minimum gradient. So what we're gonna do is that we are actually finding the minimum of the gradient curve, right? In this sense, dy dx. So we can say that d2y dx squared is the gradient of the gradient of the curve, right? So I know it's a bit confusing, but first let's differentiate this, right? Dy dx is equals to 8x squared. I'm going to do this a little bit faster, minus 18x plus 5. Okay, so we have the gradient curve. So this 8x squared minus 18x plus 5 is a quadratic curve, and it's the gradient curve. And we're not going to find the minimum of this curve, right? We're going to treat this as an equation. So this is the equation we want. To find the minimum gradient, we want to find the so you're going to treat it like an equation, right? So to find the minimum gradient, we're going to use the gradient of this minimum gradient, which is d2y dx squared. Okay, its d2y dx squared must be equal to 0. Correct? So let's find d2y dx squared. And this will give me 16x minus 18. So to find minimum gradient, 16x minus 18 is equals to 0. So x is equals to 18 divided by 16. We're going to divide by things here, so 9 over 8. Right? So at this point, x equals to 9 over 8. The gradient is the minimum, right? I know it's a little bit confusing, but we need to prove that it's the minimum, right? So we're going to use d cube, right? So technically, yes, if you're going to use y as your first curve, the second derivative test is d2y dx squared, right? So what I'm saying here is, let's go by an order. So if y is the curve, right, dy dx is the gradient, correct? And then d2y dx x squared, you differentiate dy dx. In the sense, this is the gradient of y, right? And this over here is the gradient of dy dx. So when we want to prove a minimum or maximum or point, we actually use the second derivative test over here, okay, which is d2y dx squared for y. But now I want to prove that this value here is the minimum gradient. So I need a second derivative test of dy dx, which is not d2y dx squared, right? Okay, we're going to use d3y dx cube. Okay, right? To be able to, so this is the second derivative of dy dx. So we're going to differentiate d3y over dx cube, which miraculously gives you just 16. Okay, since d3y over dx cube is more than 0, the minimum gradient. Okay, so what is the minimum gradient? Is actually you're gonna sub dy the minimum gradient is actually equals to 8 times 9 over 8 square minus 18 times 9 over 8 plus 5. You're gonna use your calculator over here. Okay, because if you don't use your calculator, yeah, it's gonna be very hard. Right, so this value will be the minimum gradient. So this minimum gradient is not equal to 0. Just to clarify. So let's key that in. Okay, and while you're keying that in, I just want to say that this is quite unique to mathematics, where the gradient just keeps the gradient of the gradient, and we want to understand that concept well. And the minimum gradient here is negative 5.125. Okay, so and it occurs at x equals to 9 over 8. This is very important. Okay, why is the d cube, why is the second derivative test for dy dx important? You need to show that it's a minimum, because remember when if we are finding gradient, we will usually use dy dx over equals 0, right? That doesn't really tell us whether it's a minimum or maximum. So we need to prove that this value at x equals to 9 over 8 is actually minimum, and so we do a d cube y over dx cube, which happens to be always a positive value because it's just simply differentiate this. So this is the second derivative test. Okay, I'm just write it down. This guy is the second derivative test, not for y, but for dy over dx. Okay, so this is a little bit tough question because they expect you to translate the gradient into another function, and you are finding the first derivative and the second derivative of this new function, which is just dy dx. Okay, I'll leave you here.